Hola! Okay, today we are going to look at an introduction to inverse functions. So, inverse functions I think are a lot of fun because they kind of are like these little backwards puzzles. So, you should have something that looks like this. I'm going to make a couple little minor adjustments here. Work with me for a second. Okay, so we're going to look at inverse functions. So inverse functions are basically when we have a function that reverses the process of another function. So an inverse function has this notation. Do you see this little f to the negative 1? We're going to read that as the inverse. We're going to read that as the f inverse of x. All right, that's the terminology here, is the f inverse of x. We don't say to the negative 1. And what an inverse function does, so an inverse function is going to invert or kind of reverse x and y. So we're going to take our x and our y, and we're going to switch them, and they're going to become yx. So that could also look like if y equals f of x, then that means that x is going to equal f of y. So this is not an exponent. F to the negative 1 of x does not equal 1 over f of x, because that would be a reciprocal, right? So that's not what we're getting at here. We're just inverting them. So here's what we want to do. We're going to look at a just really nice linear function. So we're going to say that our f of x, the original function we're going to start with, is 2x plus 4. And our goal is to find the inverse function of that. Now, there's a few ways to do this, and we're going to leave this part, finding that inverse function, till the end. So the first thing we're going to do is we're going to make a table of values for f of x. So for f of x. So let's start with, negative 3, negative 2, negative 1, 0, 1, and 2. So table of values, we're just going to plug those right in, and we're going to get ourselves some numbers. So 2 times negative 3 is negative 6, plus 4 is negative 2. Negative 2 times 2 is negative 4, plus 4 is 0. 2 times negative 1 is negative 2, plus 2 is 2. 2 times 0 is 0, plus 4 is 4. 2 times 1 is 2, plus 4 is 6. And 2 times 2 plus 4 is 8. Now, to find the table of values for the inverse function, we are simply going to take these values, and we're going to spin them around and put them in here. So all of the y's are going to become the x values. So my x values are going to be negative 2, 0, 2, 4, 6, 8. My x's are going to become the y's. So negative 3, negative 2, negative 1, 0, 1, 2. I'm literally just copying them, and I'm putting them in the opposite place. An inverse function truly is just a complete reversal of your x and y's. Now, come down here and let's graph this. So I think you're going to be surprised, but think about, what do you expect to see? What do you think is going to happen when we completely invert these? So let's graph f of x. I'm going to graph it in red. So I'm going to graph negative 3, negative 2, negative 2, 0, negative 1, 2, 0, 4, 1, 6, and 2, 8. Okay? So I've got this nice linear line, connect my points. It's going to look like that. Okay, now let's graph. Make sure you label this. So this is my f of x. So now let's graph our f inverse of x. So that's going to be -2, -3, and 0, -2, and 2, -1, and 4, 0, and 6, 1, and 8, 2. So if you come over here, graph that. Wow, my graphing skills, stellar. Okay, so this is what it should look like. Now, if you'll notice, they are going to intersect. There's going to be a point of intersection here. But what's actually happened is if I go over here and I take a little invisible line, and if I do this and draw myself a perfectly diagonal line, what this line that I just drew is actually y equals x, right? Isn't that just like the kind of parent function of a linear line is right here? Y equals x, perfectly diagonal line. What's happened is your inverse function has reflected over y equals x. So there is a reflection over y equals x. And that will happen every time with an inverse function. It will reflect over y equals x. Okay, so that's how we found that graphically. Let's talk about how to find this algebraically. So let's go back to the function we're working with, right? We've got f of x equals 2x plus 4. So to find this algebraically, we're going to undo our problem. So I'm going to start by replacing my f of x with a y. So I have y equals 2x plus 4. Now I'm going to solve for x. So I'm going to rearrange everything and solve for x. That means I'm going to move my 4, so I'm going to have y minus 4 equals 2x. Then I'm going to divide by 2. And now I'm going to have y minus 4 over 2. And if I divide both of these by 2, that makes it a little bit easier. So that equals x. So this gives me, let me clean this up a little bit. I have x equals 1/2 y minus 2, right? Because this is 1/2 and 4 divided by 2 is 2. Now my final step is I'm going to switch. I'm going to switch x and y. So I'm going to have y equals 1/2 x minus 2. And that is the final inverse function. So I'm going to come back up here to the top. And now I've actually found, remember I said we would look for this f inverse of x function later. And now I've got it. It's 1/2 x minus 2. That's what it looks like. Okay, let's take a look at one more example. Let's look at, let me see here. Let's look at -2x minus 1. So this is our original function. Let's make ourselves a little table of values, nothing too crazy. Let's say -3, make this bigger. -2, -1, 0, 1, and 2. So if I plug that in, I get 6 minus 1 is 5, and 4 minus 1 is 3, and 2 minus 1 is 1, 0 minus 1 is -1. -2 minus 1 is -3. -4 minus 1 is -5. All right, so to find our inverse function, we're going to make our reverse. We're going to flip these around. So this is going to be 5, -3. And this is going to be -2, 3, oh, I just goofed that one up. Sorry. This is going to be 3, -2, and this is going to be 1, -1, and this is going to be -1, 0, -3, 1, -5, 2. So come down here, graph those points, and we'll be able to see what our function is. So we're going to say, in black, I'm going to say -3, let's see, -3, 5, -2, 3, -1, 1, 0, -1, 1, -3, and 2, -5. Did I get that right? Okay. That's going to connect here. Okay, and then in red, this is my, this was f of x. So now I'm going to do f inverse of x. So I'm going to go over to 5 and down to 3. 1, 2, 3. And I'm going to go over to 3 and down 2. And go over to 1, down 1. And -1, 0. And -3, 1. And -5, 2. Okay, wow. My skills are stellar. Okay, and then we're going to go see. So then this is f inverse of x. So then come check out and see if we've still got a reflection over y equals x. So we should still have this reflection over y equals x. And we do, right? Like if I folded this in half on y equals x, I would have a symmetrical thing. So if I go find this algebraically, remember, we're just reversing things. So we're going to have, we had y equals -2x minus 1. So we're going to solve for x. So I'm going to move everything over and get y plus 1 equals -2x. Divide out my -2. I'm going to divide both terms. So y divided by -2 plus 1 divided by -2 equals x. Now we're going to switch our y and our x. Well, first of all, I'm going to turn this around. I'm going to have x equals -1/2 y minus 1/2. And now I'm going to switch my x and my y. My final step. Y equals -1/2 x minus 1/2. Now, the last little piece we need to ask ourselves is that the graph we've got right here? So look, like, do you have a y-intercept at half, -1/2? We do. We have a negative slope, and our slope goes up 1/2. So this does give us the graph we already found. So this is our final, that's our final inverse function. And we can write that with the right notation, right? -1/2 x minus 1/2. Okay, that's it. That's all there is to it. To find an inverse function, you're literally just swapping x and y.